start this recording. All right, so check this out. We're talking about quadratic equations, right? And I remember talking about quadratic equations and talking about parabolas. And let's look at this graph over here, G5, okay? How many or actually, let's look at G6. How many zeros does G6 have? Do you see? G6, graph 6. How many zeros are we talking about here, folks? How many times does all right, if you don't know, say IDK, but at least answer me. Make sure you answer me. You can also say I can't see, but give me a second. Let me just work that out. All right. Okay. 2. Exactly, Jillian. It has 2. When I ask you how many zeros it has, basically I'm asking you how many times does this thing cross the x-axis? And your answer is 2, right? And if I were to ask you how many zeros does G4 have? Look at graph 4. How many zeros are we talking about here? Graph 4. How many times does this thing cross this x-axis, this horizontal line? How many times does that parabola touch it? Check, audio check. Is my audio working? Check. Audio. Hello, hello, hello. Can you hear me? All right, maybe I might have too many things running. I'll tell you what, let me just eject this thing. I'll start closing windows. Hopefully that works better. Audio, check. Can you guys hear me? Can you hear the audio? Is it better or is it still choppy? Better or worse? All right. What I was asking you is let's look at G4, graph 4. How many zeros does graph 4 have? How many times does this thing, it has 2. And I'll tell you what, if you could zoom in and look at it, I'll tell you what they are. It lands real nicely on -2, which is right here, and +3, which is right here. So this particular parabola, it has 2 answers, and not only does it have 2 answers, but it lands nicely on on numbers. So that tells me that if I wanted to factor that parabola, I can actually factor it pretty easily. Okay? Are we cool with that? Now, not all parabolas can be factored, which is why we've come up with this idea of the complete the square method or the quadratic equation, which is what we've been teaching you. Like, for example, I couldn't tell you exactly which numbers those land on, these 2 points land on, but say if they weren't really nice numbers like integers, as in like 1, 2, 3, 4, if they were like decimals, then I wouldn't be able to factor this, but I still would be able to solve this using the quadratic equation. We cool with that? Or if you guys like using complete the square. Yes, no, I agree, I don't agree. I understand, I can hear you. I need you to make sure you guys tell me what you respond to me, because I don't know if the audio is coming through all right. Check, hello. All right, good. So, here's another thing. How many zeros does graph 5 have? Let's look at G5. How many zeros does this thing have? 0. No, it has some. It's got one of them. How many times does this parabola touch this horizontal axis? That's what I'm asking. And my answer is it touches it once. It just kind of comes down and then just kisses it and then comes back up. I didn't ask how many times does it cross the horizontal axis, the x-axis. I asked how many times does it touch, and in this case it only touches once. Does that make sense to you? All right. So there's also another possibilities. Let's look at graph 1, 2, and 3. How many times do those graphs touch the x-axis? Zero times. Yes, exactly. So a parabola can touch a horizontal axis 2 times, 1 time, or 0 times. Right? If we're talking about a parabola, it can have one of 3 different possibilities. It could cross the x-axis twice, it could touch it once, or it could not touch it at all. Now here's the thing. We can't solve this using standard factoring methods. We can't solve when a parabola doesn't touch the graph at all. We could graph it using the complete the square method and all that kind of stuff, but we can't solve it. So what I'm going to show you today is what does the quadratic equation look like for graphs that touch it twice, graphs that touch it once, and graphs that don't touch the x-axis at all. And what we'll be able to do is, without having to graph something, we can take a look at an equation and say, that graph is going to not touch that equation at all. So here's what we're going to do. We're going to take a look at this graph. All right, this graph right here is a function that is in vertex form. All right, describe for me how that graph is going to look. I'll pull up Desmos and we'll take a look at exactly what it is. But tell me, what do you think that graph is going to look like? Since it's in vertex form, it's kind of easy for us to talk about. What is it going to look like? It's going to go to the right 2 and up 1. Very good. I like it. Now, imagine a parabola, okay? Put it in your head, move it to the right 2 units and up 1. How many times does it cross the x-axis? Can you guys think about that? How many times does it cross the x-axis? Think of a parabola in your head, move it to the right 2, push it up 1 unit. How many times does it cross the x-axis? Does it cross twice, once, or no times? None. Very good. Awesome. You can think of these things in your head. So this one, we can look at this vertex form and say, oh, this thing is not going to cross at all. Now, I'll tell you what. Let me just pull open Google Chrome. I'll pull open Desmos, and I'll pull open, I'll start typing up some math for you guys so you guys can see us do some math, and we'll see if we can figure out a pattern between all of these numbers. Desmos graphing calculator. What is trophy? I wonder if I have a virus on my computer. And then we'll also pull open write latex equation editor. Okay, give it a second. I want you guys to pull out a piece of paper and make a table like this. I won't be able to fill in the blanks for you, so you guys got to do that. But you guys go and make a table that looks kind of like this, and I'll work with you and fill this out because I want us to discuss these things that I want us to discuss these things. Okay? So we're looking at this, and the function is moved to the right 2 and up 1, and we know that there are there are no zeros to this graph. It doesn't cross the x-axis at all. You can take a look at it by looking at if we were to graph that thing. Like you said, this is a regular parabola, as you said, Jillian, that's moved to the right 2. There, you can see that there. And then I'll put the plus 1, and that moves the graph up 1. So we take a look at this parabola, and it's a nice parabola like that. Are we cool with that? Now, let's put this parabola into standard form. Because right now it's in vertex form. Let's put it into standard form. Now you guys are thinking, well, why are you using standard form? Because standard form is so useless. Remember, we keep talking about this. Vertex form is where it's at. Why would you even want it in standard form? And my answer to you is this. Because standard form is what we're going to want to be using when we use the quadratic equation. So bear with me for just a second. Are we cool? Can you guys still hear me? Is the audio cutting in and out, or is it still good? All right. Do you guys... All right, so what I'm doing right now is I'm changing something into standard form. I'm taking it and I'm putting it into standard form. Let me quit some of my applications, see if I can get the audio to work better. Yeah, I need all of those apps open. All right. So what I'm saying here is this right here is in vertex form, but I need to put it in standard form because I'm going to start playing around with the quadratic equation. So let me show you, and I want to kind of get an understanding, a feel for this. And what I need you guys to do is make a table that looks kind of like this. So take notes on what we're doing, all right? So we have x minus 2 squared plus 1. If I want to change that to standard form, that's pretty easy. All I do is this. Give me a second. Are we cool with that? I basically just multiply this whole thing out. So then I'm going to want to FOIL that top one, so then this becomes squared plus 4x plus 4. Is anyone confused as to this line from here to here? Do you guys all understand how I got that? Yes, you're confused, or yes, you understand? I asked 2 questions. I'm sorry. You're going to have to clarify that more. Okay, good. All right. Okay. So all I did was I combined those last 2 numbers, and I made it x squared minus 4x plus 5. Are we cool with that? So I want you to write this down. I want you to write down the fact that x squared minus 4x plus 5 is is the standard form of this. So this vertex form is the same as this standard form. Are we cool? So write that down for me and keep that in mind, because I'm not going to memorize all of these things. All right. Here's what I want to do. I want to take this and put it into the quadratic equation, and it might tell us something. So let's take a look at that. All right. I'm going to take this, I'm going to put it into the quadratic equation. Identify for me what is A, B, and C. If I have it already in the standard form, what is... Oh, oops, sorry. What is A, B, and C? And come on, somebody else besides Jillian should answer. You guys can all hear me, hopefully. Where are you guys at? Talk to me. What is A, B, and C? All right, well, I appreciate Jillian answering. Let's go with that. A is 1, B is negative 4, and C is 5. All right, so I'm going to plug this into my quadratic equation. First, I got to remember what it is. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. So as Jillian pointed out, the quadratic equation, plugging it into there. B was negative 4, right? So then this becomes negative 4, which is also known as positive 4. B squared, that's negative 4 squared, so I'm just going to put that as 16. Are we cool with that so far? A was 1. C was 5. And then 2A, well 2 times A is just 2, so I'm just going to put a 2 there. Are we good with this so far? Okay. Can I change this 4 times 1 times 5? I'm just going to put 20, if that's all right with you. Yes. No. Is that all right? Okay. And the reason being is just because, well, that's what 4 times 1 times 5 is. Notice that the thing inside of the square root is negative 4. Because 16 minus 20 is negative 4. Here's the problem that we have. There's no such thing as the square root of a negative number. Right? What is the square root of a negative number? Okay, here's my question. First question, can everyone hear me? And I need everyone to answer. Raimana, Shanebex, Jillian. Well, Raimana got kicked out, I guess. I don't know what's going on today. But can you hear me? All right, good. Second question. Do you understand why there is no such thing as the square root of negative 4? Yes or no? Good. I'm glad that you answered no. I'm glad that you said you don't understand. Why can't I have a square root of negative 4? Well, let me tell you this. The reason being, okay? What is the square root of positive 4, Julian? what I'm asking you is what times what? What times itself will give you positive 4? 2. Okay? What about negative 2? Does that work as well? What times itself? So Jillian, you just told me that 2 times 2 equals 4. 2 times 2 equals positive 4. Right? That's what you told me. And that's why the square root of 4 is 2. Because 2 times 2 is 4. And I said, well, what about negative 2? So is negative 2 times negative 2, what's that equal to? It equals 4 as well. All right, cool. So negative 2 can also be a square root of 4, right? If I ask you, what is the square root of positive 4, you would tell me, oh, well, it's either 2 or negative 2. Because 2 times 2 is positive 4. Also, negative 2 times negative 2 is also positive 4. They both work. We cool with that? But, Jillian, if I'm asking you, what is the square root of negative 4, then what I'm asking you is, what number times itself gives you negative 4? And I don't have an answer for that. Because I can't think of a number where you can multiply it by itself again and you can get a negative number. Because if I choose a negative number and I multiply that by a negative number, it will give me a positive number. So I can't choose negative 2. I mean, I guess one of you could say, well, wait a second, what about 2 and negative 2? You can multiply 2 times negative 2 and get negative 4, right? You guys can tell me, well, what about negative 2 and 2? That will give you 4, right? But my answer to you is this. Yes, but I asked you what number times itself gives you, what number times itself gives you negative 4? Negative 2 and 2 is not itself. You're not multiplying it by the same thing. You're multiplying them by 2 separate numbers. That's not what I asked you. I asked you what number times itself gives you negative 4. And for that, there is no answer. Do you guys see what I'm getting at here? So this is why, when I say there is no such thing as the square root of negative 4, well, there's no such thing as the square root of negative 4. That's why. Or at least, there's no number I can think of off the top of my head, a real number that I can think of, that gives me the square root of negative 4. So at this point, we have to stop. Our quadratic equation kind of falls apart. It doesn't really fall apart. I'll show you what the square root of negative 4 is. Us mathematicians have come up with an idea for it. But essentially, we're dealing with the square root of a negative number. There's a problem. I guess my question is, when does, at what x value will you get an answer where you'll have the square root of negative 4? And the quadratic equation is telling us, wait a second, there is no square root of negative 4. And then basically the math is saying, yes, exactly. Which is why there is no 0. There is no x, solution. There's no point at which this thing crosses. Do you guys see? It's almost like the math is telling us, I'll tell you, you're asking, by using the quadratic equation, you're asking the math. Give me a second, hold on. Hello? Hey. I'm actually in a big string of classes today. Can I call you back? Okay. Yeah, sure. Actually, I think I did send you it in an email. You might want to just look it up. I know I sent you an email with her number before. So it might be in your history. But I'll send it to you. Oh, okay. All right. I'll email it to you. No problem. Okay. Love you. All right. Sorry about that, you guys. It's almost like you're taking the standard form and you're saying, hey, math, or quadratic equation, I'd like for you to help me out here. I want you to tell me, when does this thing cross the x-axis? And the computer, or the math is telling you, well, I'll tell you that answer when you can tell me what the square root of -4 is. And then you say, well, I can't tell you what the square root of -4 is. And so the math says, well, I can't tell you when this thing crosses the x-axis, because it doesn't. You say, wait a second, math, the square root of -4 doesn't exist. And then the math says, oh yeah, well that's good, because where this thing crosses the x-axis doesn't exist. It doesn't cross the x-axis. Does that make sense to you? All right, let's try something else. Let's make this -1. I'm gonna just change it up a little bit. How many times does this thing cross the x-axis? I just changed the equation. I'm doing. Let's do another problem now. It crosses it twice. Very good. All right. This is the vertex form. We can think, how many zeros are there? There's 2 of them. Okay. Oh, darn. 1 second. Okay. Let me just change this real quick to x -2 squared -1. All right. Let's turn this into standard form. That's pretty straightforward to do. I'm going to do it pretty quick. X squared minus 4x plus 4 minus 1. Are we cool with that? Got it? All right. And then basically this becomes x squared minus 4x plus 3. Are we good? All right. Now, what I want to do is I want to use the quadratic equation on that. So let me just write down the quadratic equation. And let's see, I'm going to fill in the pieces right here. In this case, this is -4, so that would actually become +4. Plus or minus, I'm going to make this a 16. I'm going to do 4 times A times C. What is 4AC in this case? What is 4 times 1 times 3? Four times 1, -12. Yeah, 12. And then 2A, A is 1, so now I'm just going to delete that. Are we cool with what I've got down there so far? All right. 16 minus 12, that's the same as 4. So really what I'm dealing with, oops, what happened? So really what I'm dealing with is the square root of 4 of +4 is 2. And then let's take the plus version first. What is 4 plus 2, and then divide that number by 2? Four plus 2 divided by 2 is 3, I think, right? And then the minus version is, what is 4 minus 2 divided by 2? Well, that's 1. Because 4 minus 2 is 2, divide that by 2, 2 over 2 is 1. Are we cool with this, or did I lose you anywhere? All right, so again, the quadratic equation actually told us, oh, it crosses at both 3 and 1. Do you see that? So I guess the thing I really want you to look at here, though, is look at this number. When it did, look at the number right here. The thing to us that was important is this this number right here. This number right here is a number that's positive. We can take the square root of a positive number. We're good. Whereas in the example before, this number was negative. We can't take the square root of a negative number, so we kind of had a problem, which made sense because the thing didn't cross the x-axis. So it kind of motivates me to point out to you a very special part of the quadratic equation. That special part is this stuff inside of this square root, the b squared minus 4ac. If that number is a positive number, then how many zeros are you going to expect to find? If b squared minus 4ac is a positive number, how many zeros do you expect to find? How many times will it cross the x-axis? Twice. Very good. If b squared minus 4ac was a negative number, like this one, how many zeros do you expect to find? How many solutions do you see? None. You can't find any because the thing doesn't cross the x-axis. So this b squared minus 4ac is kind of important, which is what we call the discriminant. I think that's how you spell it. It's b squared minus 4ac. All it is it's not another equation I'm teaching you. All it is it's the inside of the square root. That part of the square root, or that part of the equation, the b squared minus 4ac, it's the stuff inside of the square root. That is what the discriminant is. And the discriminant kind of gives us a lot of hints as to what this graph is going to look like. Are we cool? So I tell you what, I'll make a little table, and we'll do a lot of this stuff real quick. All right, Drive. Do you guys know how to use Google Spreadsheets? I'll show you. I'm just going to make one up. Okay, ready? I'm going to go New, Spreadsheet. I just went into my Google Drive. I typed in New Spreadsheet. All right, here we go. Okay. So, here's what I'm going to do. I'm going to make a column A, B, and C. This is the A x squared. Here's my B, B, X, and there's my C. Got it? So I'm just going to type in what is A, B, and C for this one. So this is 1, -1, and -6. Are we cool? All right, now this column over here, I'm going to call this column the discriminant. D-I-S-C-R-I-M-A-N-E-N-T. Or N-A-N-T, I'm not sure. I don't spell it. Anyway, what is that? That's b squared minus 4ac. So that would be equal to this number squared minus 4 times this number times c, a and c. So in this case, the discriminant is 25. Okay? See this graph right here. Do you expect this graph to cross the x-axis twice, once, or 0 times? I'll give you a hint. The discriminant is positive 25. Twice. Very good. Awesome. And we could put it into the quadratic equation and figure it out. But essentially, all I really want to know is, does it cross twice, once, or whatever? So I'll tell you what, let's copy that formula down there and we'll put in some more numbers. What about 3, 12, and 16? I'm just doing S2. This is the next one. So, if I plug in 3, 12, and 16 into here, my discriminant is -48. Do you expect this graph to cross twice, once, or none times? None. Very good. Awesome. All right, let's see. Let's do 1, 2, and 3. All right. For this graph, for S3, the A, B, and C is 1, 2, and 3. I had my spreadsheet calculate out the discriminant. All you have to do is take what is b squared minus 4 times 1 times 3. So that makes sense because b squared is 4. 4 times 1 times 3, that's 12. So what is 4 minus 12? That's -8. So this is just calculating out the discriminant for me. But does this graph cross twice, once, or none? None, absolutely. And I'll tell you what, I'll prove it to you. If I were to graph x squared plus 2x plus 3, let's look at where that graph is. That graph is up here. How many times does it cross the x-axis? None. But we were able to figure that out without having to graph it. We were able to figure that out by just looking at the discriminant. Do you see the advantage here? All right, let's do. There's one more that I need to share with you guys, and then I gotta go. Let's see. All right, let's take a look at this graph right here. X squared plus 2x plus 1. Here's another problem. So my A, B, and C is 1, 2, and 1. Let's see what that does. What is the discriminant here? If I plugged in A, B, and C is 1, 2, and 1, the discriminant is 0. How many times does it cross the x-axis? Or, I guess more like, how many times does it touch the x-axis? Once. So maybe that's another rule. Whenever you have a discriminant that's equal to 0, then your graph only crosses it once. I mean, here, look, I'll tell you what. Give me a second. All right, essentially, watch. I'm going to take this, I'm going to plug it into my quadratic equation. Watch this. Check this out. Ready? Negative b, that would be negative 2, right? Plus or minus the square root of b squared. So what is 2 squared? That's 4. Minus 4 times a times c. Now what is a and what is c? A and c are what? In this equation right here, x squared minus 1. All right, so a and c are 1. So what is 4 times 1 times 1? Well, shoot, that's just 4. I'll divide it by 2a, and a is 1, so I can just get rid of the a. Are we cool with that? All I did was I plugged in the numbers. Now, inside that square root, notice what happens. 4 minus 4, that's 0. And like I said, the discriminant is 0, right? We already knew that, or we talked about that because we had our spreadsheet calculated out for us, and it told us, hey, the discriminant is 0. So we know that, right? So what is negative 2 plus 0? What is negative 2 plus 0? Negative 2, awesome. What is negative 2 minus 0? Negative 2 still. So this plus or minus the square root of 0, by the way, the square root of 0 is also 0. So the plus or minus the square root of 0, I can really just get rid of it, right? Like I don't need it at all. And so notice how what it does is it no longer has 2 separate answers. It only gives you one answer. And in this particular case, negative 2 divided by positive 2 is negative 1. Which makes sense because Desmos told us that this thing crosses at negative 1. And it only gave us one answer. Well, why did it only give us one answer? Well, because the discriminant was 0, as we calculated it out. And when you have the discriminant equal to 0, you kind of get rid of this plus or minus part because you don't need it, right? So the plus or minus part is what gives us those 2 answers, you know, the plus version and the negative version. So essentially we just killed it. And it only gives us one answer. So to recap, I could have told you this, but I feel like we're better off exploring this stuff. To recap, if your discriminant, all right, what is the discriminant? The discriminant is simply the thing in the quadratic equation, that would be this guy right here. It's the thing inside the quadratic equation that is, it's the part of the inside the square root of the quadratic equation. If the discriminant is positive, then you will have 2 zeros, and you'll have to find them. If the discriminant is negative, then you're not going to have any zeros, and your parabola is going to be one that doesn't ever cross the x-axis. If the discriminant is 0, then you're going to have only 1 0, and your parabola will just kiss the x-axis only once, as in this case. Does this make sense to you? Cool. So that should be, actually that pretty much covers the whole lesson. Later, I'll show you how to deal with the square root of negative 1 and the square root of negative 4. That will be on Friday's lesson. But that pretty much covers discriminants at least. So I want you guys should be able to handle the rest of the homework for that one. All right, anyway, I'll talk to you guys later. See you on Friday. Goodbye.